AI video is absolutely everywhere right now, isn't it? We've all seen those mind-blowing clips that just look like pure magic. But, there's always a but, there's this little ghost in the machine that's really holding the technology back. So today we're going to tear into this really cool research paper that tackles this problem head-on. We'll find out exactly what the issue is, and more importantly, how one team of researchers cracked the code. Let's dive in.
You know exactly what I'm talking about. An AI video starts out looking absolutely stunning, totally realistic, and then, a few seconds in, it starts to get weird. It flickers, the details get all muddy, and the whole thing just falls apart. So what gives? Why does the magic just fizzle out so fast? That's the big mystery we're unpacking today. You know, this thing, it actually has a name. Researchers call it the long video problem. And it's a huge deal. Because while AI has gotten pretty amazing at creating those short 5-second clips, the ability to generate longer videos that are actually consistent and do what you tell them to do, that's been a massive unsolved challenge.
So let's be clear about what we're aiming for here. The Holy Grail isn't just making a video. It's about generating a video that can last, up to a minute or even longer, stay stable, and actually follow the user's creative direction the whole time. That's the real finish line.
Okay, so to crack this case, the researchers behind the LongV model basically had to put on their detective hats. Before they could fix anything, they had to hunt down the clues and figure out exactly what was causing these glitches in the first place. Let's take a look at the evidence they uncovered. Their investigation pointed to two main suspects. First up, we've got the flicker problem. That's just a fancy way of saying the video gets all jittery and inconsistent. And the second culprit is the fading problem, which is pretty much what it sounds like. The visual quality just gets worse and worse the longer the video runs. So what's behind the flicker? Well, imagine you're trying to make one of those little flipbook animations. But instead of one person drawing all the pages, you have a different artist draw each page, and none of them can see what the person before them drew. It'd be a chaotic mess, right? That's basically what was happening here. The AI was building the video in tiny chunks, and each chunk was its own separate project, with its own settings. That clipwise method is what creates those jarring, flickery jumps. And what about the fading quality? Okay, this one's like making a photocopy of a photocopy of a photocopy. You know what happens, right? Each time you make a copy, it gets a little worse, a little blurrier, the errors just pile up. The same thing was happening with the AI. When it relied on only one type of instruction, or modality, to guide it, the tiny errors would accumulate with each new frame, until the whole video just degraded into a blurry mess.
And boom, here's the proof right here. Just look at the image on the left. You can literally see the glitchy artifacts and messiness that comes from that single guide approach. Now look at the right. When the AI uses multiple balanced guides, the image is crisp, clean, and high quality. I mean, the difference is just staggering.
So now that they knew who the bad guys were, the flicker and the fade, the researchers came up with this super elegant two-part solution. They called it LongV. And folks, this is the breakthrough moment.
And at its heart, the whole idea is actually pretty simple and brilliant. Step 1, unify the foundation. Instead of that chaotic page-by-page approach, they decided to create one single, consistent blueprint for the entire video. And step 2, balance the controls. Don't just rely on one instruction set, combine different kinds of guidance to get the best results. Let's dig into that first step. To fix that messy flipbook problem, LongV uses something called global normalization. Think of it like setting the brightness and color for a whole movie at once instead of scene by scene. It makes sure everything looks consistent. Then it uses unified noise. Now AI videos start from a pattern of random static, or noise. By using the exact same starting noise pattern for the whole video, it's like every part of the construction is starting from the same master blueprint. The result? A smooth, coherent video.
And hey, don't just take my word for it. The researchers themselves put it perfectly in their paper. They say they adopt a global normalization strategy and use a shared noise initialization specifically to mitigate flickering and promote smooth transitions. That's it right there.
All right, part 2 of the fix, balancing the controls. This is where multimodal guidance comes in. Think about an artist painting a masterpiece. They need big, broad brushes to lay down the background and the sky. That's kind of like dense control, things like depth maps that define the whole structure. But they also need a super fine pen for the tiny details. That's like sparse control, things like point tracking that guide the specific motion. LongV cleverly uses both at the same time.
Okay, so the theory sounds solid, right? But the real question is, does it actually work? Let's get to the good stuff, the results. This is where it gets really, really cool. Okay, just look at this. This is wild.
On the left, you've got a normal video of a house cat. Longview can actually pull the motion data from that cat and apply it to a completely different subject. And just like that, it generates a photorealistic tiger that moves with all the same natural behaviors. The consistency is just unreal.
And it's not just for animals. It works on entire scenes, too. Here, it's taking the camera movement and the general flow from a video of a summer stream, and it transforms the whole thing into this gorgeous, consistent winter landscape. The water still flows, the camera still moves, but the entire vibe is changed.
Now, for any animators or 3D artists out there, this next one is a total game changer. What you're seeing is Longview taking a simple 3D model, a mesh, of a robot arm, and turning it into a fully realistic, textured and lit video. It's bridging that gap between 3D assets and photorealistic video in a way that is just wow. And of course, they've got the numbers to back all this up. This little chart is super telling. It shows what happens when they switch off parts of their solution. You can see that when they turn off either the global normalization or the unified noise, both the consistency score and the visual quality score take a hit. It might not look like a huge drop, but it proves that every single piece of their two-part fix is absolutely essential for getting that final, polished result.
So, yeah, fixing a few technical glitches is cool and all, but what does this really mean for the future, for creativity, for video production? Let's zoom out and look at the big picture.
Well, here's why this is such a big deal. For creators, this could radically streamline video production. For film and media, it just blows the doors wide open on creative possibilities. We just saw how it can bring 3D assets to life seamlessly. But maybe the most important thing is that this is a huge leap forward toward the ultimate goal, using AI for actual long-form storytelling. And that leaves us with this one kind of mind-bending question to chew on. As these AI models get better and better, going from glitchy 5-second clips to creating perfectly coherent minute-long stories, we have to ask ourselves, at what point does the AI stop being just a tool in our hands and start becoming the storyteller itself? Definitely something to think about.